Hello bachcho. So let's read this question. Show that the line r vector is equal to 2 I cap minus 2 j cap plus 3 k cap plus lambda times of I cap minus j cap plus 4 k cap is parallel to the plane r vector times I cap plus 5 j cap plus k cap equal to 5. Also find the distance between them. ठीक है? आपको जो की concept लगेगा, की concept वो है condition for parallelism, condition for parallelism and distance between a point and a plane. तो जब कंडीशन फॉर पैरेललिज्म होती है तो वो ये होती है कि अगर कोई प्लेन और कोई एक लाइन को अगर आपको पैरेलल प्रूव करना है तो आपको क्या करना है कि लेट्स से दैट प्लेन P1 इज r vector times alpha comma beta comma gamma is equal to delta. This is the equation of the plane. Line is x1 comma y1 comma z1 plus delta time or rather lambda times x2 comma y2 comma z2 is equal to 0. So let's say this is your equation of the line. Then so as to prove that these plane P1 and line L1 are parallel, what you have to do is you have to just uh, take a dot product of alpha beta gamma this vector and x2 y2 z2 alpha beta gamma times x2 y2 z2. So basically this alpha beta gamma is a vector perpendicular to the plane, and if this line must be perpendicular to the plane and alpha beta gamma is perpendicular to sorry, if the line must be parallel to the plane and alpha beta gamma is perpendicular to the plane, that means that the line and this alpha beta gamma would also be perpendicular, hence that dot product must be 0. So this is one condition. The second thing what you have to do is you have to ensure that this line doesn't lies on the plane. So you just take any random point on the line and try to satisfy whether it is on the plane or not. If it is not on the plane, then the line is not on the plane. But if that random point is on the plane, that means the line would be on the plane. The second thing is the distance between a point and the plane. So let's say this P1, again a plane, is ax plus by plus cz plus d is equal to 0. So this is a plane and you need to find the distance of the point. Let's call the point as a, which is x1, y1, z1. So the distance, we'll call this as d, comes out to be modulus of ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square मॉडुलस. प्रॉब्लम की तरफ पढ़ते हैं. सो प्रॉब्लम में हमें जो लाइन दी गई है r वेक्टर इज गिवन टू बी 2 -2 3 प्लस लैम्डा टाइम्स -1 प्लस 4 और जो प्लेन दिया गया है आई विल कॉल दिस p इज गिवन आउट टू बी r वेक्टर टाइम्स 5 1 is equal to 5. Note that this is a very popular notation where you can either represent this as 2 I cap minus 2 j cap plus 3 k cap, or you can just represent this as 2 comma minus 2 comma 3. They both mean the same thing. All right. So because the first thing that we'll show is that these two are parallel. So we know that the condition for parallelism is to establish the fact that the dot product of this and this must be 0, and hence we try to take the dot product, which is 1 comma minus 1 comma 4 times 1 comma 5 comma 1. And we know how to take a dot product, and this dot product is 1 times 1 comma minus 1 or rather plus minus 1 times 5 plus 4 times 1. This comes out to be 1 minus 5 plus 4, which is 0. Hence they both are perpendicular. The parallel line to our given line and the perpendicular line to our given plane, they are both perpendicular to each other. Hence the plane and the line must be parallel. All right. Now we have to establish the fact that this line does not lies on the plane. All right. So we have point on the line. let's call that random point to be P, and it would, let's call that random point to be A, and it comes out to be, using the parameter, we can say that random point would be 2 plus lambda, comma, minus 2 minus lambda, comma, 3 plus 4 lambda, and this is some random point, and we'll try to see whether this point lies on the plane or not. So 2 plus lambda, comma, minus 2 minus lambda, comma, 3 plus 4 lambda का डॉट प्रोडक्ट अगर मैं 1,5,1 से लूँ तो मुझे मिलता है 2 प्लस लैम्बडा माइनस 10 माइनस 5 लैम्बडा प्लस 3 प्लस 4 लैम्बडा। अगर मैं सारी लैम्बडा वाली टर्म्स को ऐड करूँ तो मुझे 0 मिलेगा कि लैम्बडा माइनस 5 लैम्बडा प्लस 4 लैम्बडा इज 0, और बाकी की टर्म्स को ऐड करूँ तो मुझे मिलेगा -5। बट देखो कि RHS के अंदर हमें इस प्लेन के इक्वेशन के RHS के अंदर +5 है इंस्टेड ऑफ -5, हेंस ये जो गिवन पॉइंट है ए वो प्लेन की इक्वेशंस को सेटिस्फाई नहीं करता है, हेंस लाइन डजंट लाई ऑन द प्लेन। Which implies that it is indeed line is parallel to plane. Now we have to evaluate the distance between the line and the plane. Now as line is parallel to the plane, we can just take any point on the line and try to evaluate the distance of that point from the plane, and we know one such point which is 2, minus 2, 3, and hence distance of line from plane, and the point that we are going to be using, and let's call that point as Q, and it is 2, minus 2, 3, and using this point we'll evaluate our distance using this distance formula, d equal to modulus of ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square, and the equation of the plane is x plus 5y plus z minus 5 is equal to 0. So this is equation of the plane, and hence the distance d would be modulus of 2 plus 5 times of minus 2 plus 3 minus 5 upon under root of 1 square plus 5 square plus 1 square whole modulus. So this is 2 minus 10 plus 3 minus 5 upon under root of 30, which is minus 10 upon under root of 30. Now note that we have taken a modulus of this, and after taking modulus we'll obtain a final answer to be 10 upon under root of 30. So this is our distance of the line from the plane. I hope you understood it well, and best of luck.